Hi guys, welcome to Success Clinic. Welcome to Success Clinic. So today on Simplified Physics SS1 syllabus, so we are going to the sixth lecture for SS1 first term. So for this, we are going to be discussing about distance, displacement, position. So let's go straight into the course outline. For the lesson outline, we have position. So we are going to be discussing about what position is. We have scalar and vector quantity, we have distance, and we have displacement. Okay, now when we talk about position, what is the meaning of position? So the position of an object, what does it mean? So position of a point in space is determined by its distance and direction from other points. Jesus. So the position of a point is in a space is given in relation to the reference point, which is called the origin. So like those of us, we have already started being conversant with graph work, whereby we are trying to plot on a Cartesian plane, that is x and y axis. So when we talk about the position of a body, position of an object, it is what is the position of this body in relation to what the reference point. So for a Cartesian plane, we know that what the origin is the point of intersection between what the x and the y axis, and our x axis, because x axis we have what we call the coordinates. So coordinates, we have the x coordinate, y coordinate. The x coordinate is what we call the abyssal, and the y coordinate is called the ordinate. So the x coordinate is the distance between that point from the x axis, while y coordinate is the distance between that point from what the y axis. So when we talk about position is what the relation of a point from a what reference what position, from a reference point. So that reference point is usually the origin. Now let's talk briefly about the scalar and what vector quantity, because we'll be making use of that for this lecture. Now what is a scalar quantity? A scalar quantity is a quantity that has what magnitude only but no direction. What is the meaning of magnitude? Magnitude means what? A numerical what value, that is to say a number. Why direction? So what we say scalar quantity has a magnitude, which is what a number but no direction. So example of scalar quantity is like time, we have distance, we have speed, we have volume, temperature, work, we have power, we have electric potential, etc. So we said that what a scalar quantity has no directional component but only magnitude. For example, the unit of time, these are unit of time, they can only be represented by the amount of time only. So it does not really tell us the word direction. So we have other examples of what scalar quantity. Now what is a vector quantity? Vector quantity on the other hand is a quantity that has both magnitude, which is what a numerical value, and what direction. So what are the examples of vector quantities? We have velocity, we have displacement, acceleration, force, momentum, moment, electric field intensity, etc. So what we'll notice about all these examples is that they have direction. So the basic difference between scalar quantity and vector quantity is that vector quantity has direction while scalar quantity does not. Okay, distance. What is distance? Distance is the length of journey traveled by a body. So how long is a journey that a body travels? So distance is the length of the path between the point where the body started and its current position. So measuring all the paths that body have passed through. So if you measure that length, it is going to give you what distance. Distance is a scalar what quantity, because for example from here to United Kingdom is what, let's say we are from here to United Kingdom is, let's say, close to 50,000 kilometers for an instance. Now it does not actually say if it is actually from here to United Kingdom or United Kingdom to here. So the direction is not really affected. So scale distance has only magnitude, no direction, and distance is measured with what? In meters. Okay, let's talk about displacement. Now, what is displacement? Displacement is a distance traveled in a specific direction. So the difference between distance and displacement is that distance is the total length of a journey, while displacement is distance traveled in a specified direction, meaning that the direction for displacement is specific, and that alone makes displacement to be a what? Vector quantity. So displacement only consider the distance between the starting point and the current point. So that's to say, for displacement there are 2 points that are important. One is where did you start, and number 2 is where are you currently. So displacement checks what is the distance between your starting point to your current point without considering how you get there. While for distance checks the distance between your starting point and your current point, considering the paths you used to get there. So the SI unit for displacement is what? Meters. But mind you, for displacement, direction must always be what? Indicated. For example, look at this example. A boy walking 500 meters to the east, turn round and walk back west, a distance of 400 meter. Now the total distance this boy walked is going to be the addition of these two, because distance is going to calculate all the paths that this boy walked, so which is 500 to the east plus what? 400 back to the west. But for displacement is going to check where did you start from. You start from this point, now you move 500 and you return back 400. So the displacement is you started at the mark 0. So the displacement is going to be what? 500 minus 400 in the what? East direction. So displacement consider the distance between the starting point and what? The end point. While distance calculate that same distance but considering the what? Path. Okay, what are the difference between distance and displacement? The difference between distance and displacement. Now we have said that distance is what? The length covered along the path of the motion, while displacement is distance measured in what? A specified direction. So there must be this word specified direction or specific direction. That is the difference between what? Distance and displacement. Distance is a scalar quantity, while displacement is what? Vector quantity. Okay, now how can we get direction for displacement and also measure the displacement? Now for us to get direction, we need what we call bearing of our object. This is a topic we have done in SS2 mathematics. The bearing of an object is from the origin is the angle which it makes with the north pole in the clockwise sense. So for bearing, for direction, one of the major direction that is very important is what? The north pole, because every compass, which is an instrument used for measuring direction, always points to the north pole because of its the middle of the compass is made up of what? A magnet. Okay, so we have two ways of specifying direction. We have the cardinal point, so which is the conventional north, south, west and east, and also we have the 3-digit notation, which starts from 00 in the north and go to clockwise manner 360 back to the north. Okay, direction that are located by cardinal point are with respect to reference to north and south, and that is because of what? The north and south pole of the magnet. Okay, now look at this example. A boy travels 30 meters westward and then 40 meters northward. Find the total distance covered and its displacement. Now for us to find the total distance solution, we draw the diagram. So the boy goes westward, so the boy is starting from here, goes 30 meters west, then when he goes to west, he now goes what? 40 meters north. So when they ask us for the distance is the addition of all the paths he have followed, and our distance is going to be what? 30 plus 40, which is what? 70. Now for displacement, we cannot do it that way. We are going to ask ourselves, where did he start the journey? it started the journey at this point and ended it at this end of this area. So by the time we want to look at it, so our displacement is actually going to join this with this. So the start point to the end point, then that is going to give us that distance is our displacement. So how to get it? This forms a triangle, and all triangles respect the Pythagoras theorem, which is hypotenuse square is equals to opposite square plus adjacent square. So our hypotenuse square is AB, which happen to be our displacement, equals to AC square plus B square. Now putting the values back, so our AB square is going to be 40 square plus 30 square, and this is going to give us 1600 plus 900, and that gives us what? 2500, the addition of the two. So square root both sides, we are going to get that displacement is going to be what? 50 meters. Now remember, for the distance gives us 40 plus 30, which is what? 70. But for the displacement we are getting what? 50 meters. But mind you, this is not yet complete, because for displacement we must have what? Direction. So for us to find the direction, we are going to say that tan theta is equals to what? Opposite over adjacent. So our opposite is 30, our adjacent is what? 40. So that is tan theta. So it means that what? Tan theta is what? 3 over 4, making it tan theta 0.75, and tan theta is actually tan inverse of 0.75. So this is our what? Direction. So therefore our displacement is going to be a combination of those two, which is 50 meters, not 36.87 west. Now if you look at it, let's go to the previous side, last view. Now if you look at this, you see that this displacement was actually what? Northwest, because this is north and it's west, so this is what? Northwest. That is the direction. Okay, now so with that we are going to say that let's go back. So we have gotten this. So the next thing now is to combine the two of them together, and the two of them together gives us our what? Displacement. So that is what? 50 meters dot 36.87 degree west. Okay, so with that we have come to the end of the class. So you can try these exercises on your own and send the answer to us on our what channel or through our email. So thank you very much. Remember to subscribe to our channel. So see you in the next and the last lecture for first term SS1. Bye bye.